So for this first one, I'm just going to walk you through the process that we use in RBL solve this. Now, the first thing that I'm noticing is that I don't have one of the equations in my system set up to where it's just like x equals, y equals, or z equals. I can't go straight to knowing what one of them is right off the top. Okay, the next thing we did yesterday when we were doing these is I looked to see is there a 2 by 2 system inside of my 3 by 3. In this case, no, there isn't. I have just one equation that has the two variables in it, but I don't have two of them, so I can't do that. So what can I do then? Well, I do have that first equation that has only y and z in it. If I could take these two and turn them into an equation that only has y and z in it, then I would have two equations that have y and z in them. And so that's going to be my strategy. Since the first one just has the y and z, I'm going to create a new equation that has just y and z. So if I take a look at these bottom two equations, if I'm going to make that all in terms of y and z, notice that means I have to eliminate the x's. You'll also notice that this one is set up awfully conveniently to be able to eliminate the x's, right?
Whoa.
All I have to do in this particular example is go ahead and add those second two equations. So if I do that, if I go ahead and I add those bottom two equations there, I end up with y minus 3z equals negative 3. Yes, you want to be writing that on your paper here. And show yourself where it came from. Show that you added those two in order to be able to get that equation. And then remember why we did that. I wanted to get that equation because I started with this equation that only had y and z. So notice I now have two equations that are both just in terms of y and z. That means I have a 2 by 2 system now. That's what we are looking for. That's what we are going toward. And so now that I have a 2 by 2 system, I can go ahead and I can solve this system. And so if I'm going to look to solve this 2 by 2 system, I of course have the usual choice. I can try to eliminate the y's or eliminate the z's, either way. I think in this case it's going to be easier to eliminate the y's because I only have to multiply one of the equations by something in that case. Now if I want to multiply one of these equations by something so that the y's will add to 0, what am I multiplying by?
-1.
Yep, -1. And so that's what I did. If we multiply that second equation, and why the second? Because I felt like it. You could have multiplied the first one too. If we multiply that second equation by -1, we get that new 2 by 2 system, and then I can solve that through for z, and then plug in to find y. All right, because this is the work that we ended up doing here, you can see that when we did that first addition, where we added these two equations in order to be able to get this new equation down here, if I had made a mistake in doing that part of the process, I'd have to wait a while to discover that I had made a mistake, right? It's a pain. You need to be very careful with these. As you probably were noticing on yesterday's homework, if you make one little mistake on these, it throws a bunch of stuff off, and it can be tough to find because we have to be really diligent, really neat with these to help ourselves find anything that might go off. So just be very careful with your algebra as we do these types of problems. You know, like look out for any possible sign errors. Make sure you don't drop a negative, stuff like that. Make sure you're multiplying everything when you're supposed to be multiplying everything. All those little details, if you get those little things that we tend to take for granted, right, you'll actually be pretty solid on these. All right, so at this point, I now have what y and z equal. I still need to find x. And just like with all the other problems we've done, I'm going to find x by plugging in. And again, I can plug into either one of these original equations. And notice I say either one. I can't plug it into the first one, right? The first one doesn't have x in it. It won't help me find x. So I got to plug it into either one of those second two that have the x in it. I'm going to go ahead and plug it into the middle equation. Again, just an arbitrary choice. And so when I plug in there, then it's just a matter of going ahead and working it out. And we can solve it out and find out that x equals 1. And again, make sure you got all this work written out on your paper, because this is now our final solution. All right, now that we found the solution, I want you to again see what this is really meaning. Yesterday I was kind of trying to describe to you what's going on here. But so for this one, I went ahead and actually made the graph of that original system of equations. This is what that sort of graph would look like. Notice, 3 planes off in 3-dimensional space. And they're all intersecting. And you see there's lots of different intersections taking place. So for instance, right along this line here is an intersection of 2 planes. But so is this. Anywhere where we see those creases, those represent an intersection of 2 planes. So what's our solution then? Well, our solution is where all 3 of those are intersecting, which is actually this point right here. So what it told us is that the coordinates of this point where all 3 planes are meeting up is here at 1, 3, 2. So that's what's really happening in this. And what we're actually finding, if we're thinking of graphs, is that here off in 3-dimensional space, all of these planes are intersecting at that specific point. It's now time for you to use the method that we just did on your own. I'd like you to now apply what we are just doing to this problem. So write it down and then start working it through using the example that we just did. Now, as you are venturing forth and making your first step, be planning ahead, doing a little bit of strategy. You'll notice here that the middle equation has only x and y in it. We're going to try to use that to our advantage. So what we're going to do is we're going to try to make another equation that has just the x and y in it. So make that your goal here. You're going to create a second equation that has x and y. In order to accomplish that, you are going to need to be using the first and the third equations. You're going to need to combine those into an equation that just has x and y in it, so plan on making those z's eliminate. So that's your goal here. Take the first and the third in this one and make those z's eliminate out. Now, in order to make those z's eliminate, I multiplied the top equation by 7. So this is what my work ended up looking like as I started moving that direction. Now, if I add those 2 equations together now, I end up with this negative 62x minus 26y equals 160. Yeah, the numbers sometimes are going to get kind of big on these, and that's just going to be the way it is with 3x3 systems. All right, so remember what I was doing there. I was trying to come up with a new equation in terms of x and y because I had an equation at the start in terms of x and y. So I'm going to turn that into my system of equations, my 2x2 system that I'm then going to solve from there. And yes, some of these numbers end up being a bit big and unwieldy. I end up multiplying by negative 62 of all things. But we work with whatever the numbers tell us we got to work with. By multiplying that second equation by negative 62, I can make those x's eliminate, which seemed like the easiest way, rather than trying to make 26 and 3 into the same thing. And so once I've gotten to this point, I can then go ahead and do my addition. And if I do the addition of the equations there, I end up finding the 160y equals 160, therefore y is 1. Plug that back into any of the equations. I usually like a nice simple one that only has the 2 variables in it at this point. So I went back to this one. That's where I'm plugging in there. And I found my x value. All right, and now that we've found 2 of my variables, I need to find the third. In order to find the third, I'm going to take the 2 that I found and plug them into one of the original equations. And again, I can't plug it into the middle one because it doesn't even have z in it. But you could choose either the first or the third in this case. I chose the first, but again, it's as much an arbitrary decision as anything. There's nothing that told me I had to use the first instead of the third here. And so when we work that through, we end up finding that z equals 6. And we are now done with this. That is what we are working toward. This is the last problem that we're going to do. And this one, rather than me just showing you all of the work and all that, I want you to work this one all the way through yourself. I'll give you the answers here in a few minutes, but I'm not going to give you all the work because I want you to start being able to look back at your own work and find any possible errors. So, write this one down and go ahead and solve it out.